Hey guys, Mr. Milton here. Today we're going to talk about dilations. At the end of this video you should be able to dilate a figure using a given scale factor, and you can find the scale factor of a dilation. Okay, a dilation is a transformation in which the pre-image and the image are similar. Okay, not congruent. And so, this means that the angles of the figure are congruent, but the side lengths are not. Our side lengths are proportional, so not congruent. Okay, and since the pre-image and the image are not congruent, this transformation is not in isometry, as the other three that we discussed were. Okay, every dilation has a center and a scale factor. And for this unit, the center of a dilation will always be the center, or origin. So we won't get too far into this, so it'll always be the center. The scale factor describes the size change from the pre-image to the image. Okay, and it goes in that order: the pre-image, the original, the image after the dilation. And the scale factor is always positive. Whether the figure is getting bigger or smaller, the scale factor is always positive. Alright. Okay. The dilation is an enlargement. Two types of dilation. One's an enlargement, and it's an enlargement if the scale factor is greater than 1, and the other type is a reduction, and it is a reduction if the scale factor is between 0 and 1. Again, remember that the number is always going to be positive. Okay. Alright, so let's look at a few, and I know I have some colors in here and I don't have any colors printed. So here's our pre-image J, K, L, M. Here's our image, and we can tell because they're listed with primes. Okay, so we're going to go from the large figure to the small figure. So already we can tell that this is a reduction. And now what we'll have to do is we need to find out the scale factor. Okay, so this is going to be a reduction. We need to find out what the scale factor is, and the way that we can do that is we look at its corresponding coordinates. Okay, so I'm going to put some coordinates for J, for K, for L. So for J, the coordinate is 0, 1, 2. For K, the coordinate is 1, 2, 3, 0. Oops, sorry, nope, it's not 1, 2, 3. 1, 2, 3, 4, 5, 6, 0. Alright. And then for L, that coordinate will be 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 6, negative 4. Okay, and then I can look at the coordinates for J prime, K prime, L prime, find those coordinates, and then I'll be able to see what's happening. Alright. So at J prime is at 0, 1, K prime is at 1, 2, that one's at 3, 0, and L prime is at 1, 2, 3, 1, 2. So 3, negative 2. Okay, and so now what I'm going to do is I'm going to look at a point that's easy to compare, and that's going to be J and J prime. Okay, so I know that my coordinate with my y coordinate in J is 2, and whatever that coordinate times x, and x is the scale factor. Okay, x is the scale factor. Okay, 2 times the scale factor gave us our new point. And so now I can just solve for x here, and that will give me my scale factor. and we see that the scale factor is 1/2. Okay, and so then our scale factor is 1/2. It is between 0 and 1. Okay, again, it's positive, but it's a reduction. It goes from a large figure to a small figure. Okay, so since the blue image is smaller than the red image, we know that it is a reduction. Just writing this out again. The scale factor is 1/2. Alright, we can do the same thing here with this triangle, and we don't have to find all the points again, because the scale factor would be the same. So if we can find the scale factor in one point, it'll be the same throughout the figure. So if we look at here, P, G, Z, this is our pre-image. P prime, G prime, Z prime is our image. So the points for P is at 2, 0. G is at 1, -2. And so now I'm going to look at P prime and G prime. P prime is at 2, 3, 4, 5, 6, 0. And G prime is at 1, 2, 3, 1, 2, 3, 4, 5, 6. So at 3, -6. Alright. And so now I'm going to look at this. Again, I have a coordinate that's pretty easy to look at. And so I can say 2 times the scale factor equals 6. Okay, because I did 2 to 6. And so I divide by 2, solve for what x is, and I find that x is 3. So now in this case, this is an enlargement. Enlargement with scale factor 3. Alright. So pretty simple math there. On the back side, we are going to look at, they're giving us a set of coordinates, and then we're going to use the scale factor 1/2 to make a dilation. So we have the coordinate -4, 6, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, okay. And then 0, 4, 0, 1, 2, 3, 4. And then 2, -1, 2, -1. Okay, so that's A, B, C. Okay. All right, good. All right, now I'm going to make the scale, or use the scale factor 1/2 to make our new points. Now, before I plot those points, 1/2, that just means I'm going to multiply everything here by 1/2. And that'll give me my new coordinates. So I'll have -2, 3. B, I'll have 0, 2. For C, I'll have 1 and -1/2. Alright, and so if I want to plot those points just to see how that would look, -2, 1, 2, 3. Here's A prime. 0, 2. Here's B prime. And then 1. -1/2 C prime. Okay, and so there's my reduction scale factor 1/2. Alright, and then finally, it's we have an exercise where we are given the lengths of two of an image and a pre-image, and we're basically going to look for the scale factor and apply it to the missing lengths. So here we have a complete set of the pre-image and the image. So our pre-image is 4, our image is 12. So looking at this, we can say that the scale factor is 3, because that's what we'd have to do to PQ to get to P prime Q prime, of 4 to 12. And so we're going to just apply that. So this is 4 times 3 gives us 12. So this would be 2 times 3 would give us 6. 7 times 3 would give us 21. And now if we're going from the image to the pre-image, we have to go backwards. So instead of multiplying by 3, we have to go backwards. We'll divide this by 3 to get back to this answer. So SP would be 5. Okay, that's dilations. That is the geometry course. All right, good luck on your finals.